All right, this is going over the midterm question number 2, which really stumped a lot of you. I didn't realize I could make it so easy and it would be confusing. So the differential equation you were given was a population differential equation. There was a table in the midterm that told you about the constants R, delta, and V, but the first question was to solve this equation by separation of variables. And some of you said, well, I can't solve this by separation of variables. Indeed, you can. And that was what was tricky about it. So let me go through this. Here's the original equation right here. Then you separate variables, and here's what stumped you. You take the whole right-hand side and stick it on the bottom here. And when you do that, what you realize is that now you have a function of just p's on this side with some constants, and the other side you bring over the dp. So it's pretty sneaky, but that's what you do. Then you integrate both sides, so you get a log here. Just so you know, yes, I can do a u substitution, be extremely careful, but that takes time. So I just put it on Mathematica and said integrate this with respect to p, and I got my r minus s in the denominator. These are the kind of small mistakes that some of you make, like me. I make these kind of mistakes. So that's not a picture I wanted you to see, but let's go back to this one here. Let me rotate this one. A hack today. All right, so then once you're at this point, you solve for p. Notice that the right-hand side had a b on it, but then when I this is going to be a new c after I integrate, after I multiply through by r minus delta, and then I exponentiate both sides, so I get this puppy over here, and then I simplify by bringing the minus b over first. And then this is really a new c. I redefined c by absorbing the constant. Up here, I multiplied my old c by r minus delta. That's a new c. So they're absorbing constants as you go along. So it's not the same c. And then over here in the final version, after I divide through by r minus delta, I get this p over here. So it's again a new c. It's the old c divided by r minus delta when I did the multiplication. So this is what I get as my final answer. Okay, so let me go to the next picture. The next question was to solve by integrating factor, and most of you got this. You would just bring the r minus delta p to the other side, rewrite it as a derivative. I just sniff check myself. I make a lot of errors, so I made sure that by product rule, I get back to where I started as a multiple of e to the minus r minus delta. And then I integrate both sides, so I get this guy here with the plus c. And then I solve for p by multiplying through by e to the r minus delta p. And I get the same thing as I got for number 2a. So go back to here. The next step, I actually, I always tell you I try to go for the easiest way. I didn't want to remember the syntax for Mathematica, so I went to ChatGPT and I told it to solve the differential equation for me, and it started giving me a long explanation. And I said, I cut it off. I said, I don't want the steps. I just want the answer. And it freaked out. It didn't want to do that. So I asked it a few times, just don't give me the steps, just solve it for me. And it just wouldn't do it. And so I eventually got an answer, and it very carefully noted that if r is equal to delta, I'm going to have a different case, but this is the answer I'm looking for down at the bottom. By that time, I realized my idea of not going to Mathematica was a bad one, and I ran it on Mathematica as well. The command was dsolve. I just didn't want to remember exactly where everything's supposed to go, but apparently on my first try, I got it right, and I get the same solution that I got for the integrating factor and separation of variables. So by this time, I'm pretty confident that the answer is correct. And now, the last part was to look at whether the right-hand side is quasi-positive. So you want to make sure that when the state variable is 0, that your derivative is positive so that you are increasing and you're not going to go below 0. And the first derivative, the right-hand side, is r minus delta p plus b. If I set p equal to 0, I get b, which is positive. So the solution is going to be non-negative. So that's it for number 2.